Hello and welcome to Maths with Mr Amison. Today I'm going to go through a multiple choice quiz on 3D Pythagoras. If you need to recap how to do Pythagoras in 3 dimensions, then please watch this video here or follow the link in the description below. I'm going to start off by showing you 5 questions. I'm going to give you a chance to think about each one. So on each question, please pause and have a go. Okay, now you've had a chance to have a look at each of those questions, let's go through the answers. So for question 1, you should have got the answer of triangle CHB. Triangle ABG goes from here to here to here. Now that triangle has a right angle at A, at the point A, GAB. That angle there is a right angle. Triangle CEF, or CEF, we have a right angle at E. The point here is both of those triangles have an edge that goes along one of the edges of the cuboid and an edge that goes along one of the faces of the cuboid. And that's absolutely fine. That works in making a right angled triangle. Just like going from A to B to D along 2 edges would work, or A to B to F. That would work as well. C to H to B, however, C to H to B, while they both go along faces of this cuboid, C to D to B is the right angle. But if I stretch this point up here, you can see that both of these lines get longer. This line stays the same, and therefore, according to Pythagoras theory, you wouldn't get an answer that's quite right. So this angle here would in fact change, and it would no longer be 90 degrees. Therefore, triangle CHB is not right angle. What triangles would I use to calculate the distance between A and D? Well, A and D is this line here, so I could use the base. I could use ACD or ADC. Or I could use ABD. It really doesn't matter which one of those I use, because both of them have the length AD as the hypotenuse of a right-angled triangle. So you don't need any more information than that, because the length AB is the same as the length GH, and the length AC is the same as the length BD. So you've got the dimensions for either one of those triangles. Question 3. To actually calculate the distance between A and D, well, if we have the length 8 centimeters as AB, then 6 squared plus 8 squared is equal to 100. Therefore, according to Pythagoras theory, AD is equal to 10 centimeters because it's the square root of 100. Not forgetting to square root when you use the Pythagoras theorem. Question 4. To calculate the distance between A and H, after I've calculated AD, it would make most sense to use the triangle ADH or AHD. AHB could be used to calculate the length of AH, but it doesn't make sense to use that triangle if we've already calculated the length AD. Because ABH, we would have to calculate the length BH first to be able to use Pythagoras theory to calculate AH. So it makes more sense to use AHD. Question 5. How would we actually calculate it? Well, AH, using Pythagoras theory, AH squared is equal to 10 squared plus 5 squared. And it's worth noting that using Pythagoras theory, you may come across a squared plus b squared equals c squared, or c squared equals a squared plus b squared. Now either of those can work, it doesn't matter which one of those you use. So in this case, ah squared is equal to 100 plus 25, AH squared is equal to 125. We square root that, AH is equal to 11.180, and it goes on. Thanks for watching. Hope you found this useful. Speak to you soon.